Welcome you all my lecture series of data structures. In today's video, we are going to see about one design thinking based approach of why we use the tree data structures instead of at stack and queue. So already you know that what is a data structure? It is a way of arrangement of data efficiently in the computer memory. So why we are structure the data means for accessing the data and also for retrieving and adding the data in less amount of time, and also to occupies the space efficiently. So the efficiency of accessing and efficiency of storage, we have to structure our data. That is the main thing for the data structures. In the data structures we have several types. One is a linear and non-linear, but some application based upon the applications we can select the data structures. So in the last video we have seen the stack and queue data structures, uh, but in today I will explain one scenario. So we find out which data structures we are going to use. For example, the Maria preparing her family tree. She has her grandfather as the head of the family. Her grandfather has the three sons and one daughter. Her aunt and uncles have one son and one daughter each. So Maria is the only child of her father. So this is the statement. From this type of statement, we have to represent some data structures. We are selecting the stack means the stack is an arrangement of data from last in first. So it is like the piles of plates and uh, one after the another we can arrange it. But this problem statement, it is a scattered one. It is scattered like we have a grandfather. The grandfather have a it is like a hierarchical manner. That is not a sequential manner. So stack is a sequential data structure arrangement. And first next we consider the queue data structures. In the queue also the sequential order, one after the another. For example, for every node or every element we have a successor and predecessor. So that data structure is also not applicable in this problem statement, in this scenario. So what is the thing we have to do? Next we go to the non-linear data structures. In the non-linear we have the graph and tree. So next confusion is which data structures we have to select, either the tree or graph. So for example, this is that this statement. For example, we have a grandfather have the four children, and also the each children have that some next child. So this is the scenario we have to explain. So the graph means it is that either we have edges and nodes, all are interconnected, but this is like a hierarchical. So instead of graph we can select the tree data structures. The tree is a non-linear data structure, is used to represent the hierarchical representation of our problem statement. For example, first we have defined what is a tree. So tree is a non-linear arrangement of every node attached to one or more nodes directly or directly next level. So in this data structures, the top most node is called as a root. So the top node, here the grandfather is the root, and the connections between the nodes are called as an edges. The nodes that have no children are called as a leaf nodes, and also the non-root and non-leaf nodes are called it as a internal nodes. Here the father, Maria's father and her aunt and uncle are the internal nodes. Grandfather is the root of Maria, so the Maria is the leaf node. Next thing, we have to find out what are all the ways to represent this type of data structures. So we have to ideate the implementation ways of representing the data structures tree. So there is a two way of implementation. One is that array implementation, other one is a linked list implementation. So the array implementation means for every we have it For every, for example, we have a root means root is in the location of 2i means the child is in the location of 2i plus 1, and his and this is the way the array implementation is represented. Next is a linked list based implementation means for every node we have a left and right child. Suppose there is no left child means that term is mark it as a null representation. So this is the two way of representing the tree data structures. So now we will see the how we can represent our problem statement in using the tree data structures. Here we have a grandfather. So the grandfather have the four child, that is the two uncle and one auntie for the Maria, and next for each uncle have a cousin. We have a each uncle have a son and daughter, and also Maria only the one child for her father. So this is the representation of that problem statement in terms of the tree data structures. So here in these data structures we can represent either in the array or the linked list representation. So instead of a linear data structures, we can select the non-linear, and also in the non-linear which one is the hierarchical representation means tree data structures. So that data structure is best way of representing that problem statement. Thank you.